Hi, I'm Tyler Sparks with the SSL Lab at the University of Florida. This is our LEGO IoT demo. This demo is made to replicate an industrial control system for an entire city. Here we have a downtown area, the Ben Hill Griffin Stadium here on the University of Florida, an industrial district with a factory, carousel and Ferris wheel, and then a train with train tracks and a station. Here we have our control panel for the LEGO demo. We have a live camera feed, which you can move to see different parts of the city by using the controls. We have the city controls, where you can turn on different zones of lights, the traffic lights, and as well as adjusting the brightness for each. We have the factory controls on and off, the track switches for the train speed control, Ferris wheel speed control, carousel speed control, and then the sensors on the track so that you know the values of the sensors, where the train is, and where it was last seen. Now we're going to show off the downtown area of the LEGO demo. This NodeMCU controller here controls all of the lights in the downtown area. It corresponds to this section of the control panel. There's 3 zones and then an additional one for the traffic lights. Zone 1 and 2 are street lights, Zone 3 are the building lights, and then as I mentioned before, the traffic lights have their own switch as well. The 3 sliders beneath are to adjust the brightness of each. So I'm now going to turn on Zone 1. Zone 2, Zone 3, and then the traffic lights. And then I'll adjust the brightness of Zone 1. And as you can see, all the buttons are being controlled here. Now we'll talk about the theme park area of the LEGO demo. Both the carousel and Ferris wheel are driven by NodeMCUs attached to motor shields. The motor shields are attached to the 9-volt batteries and output to the DC motors. On the control panel, there are sections for the carousel and Ferris wheel. Both can go forward and in reverse and have multiple settings for speed. And then reverse as well. And the carousel can do the same. Okay. Now for the factory. The factory is controlled by a NodeMCU connected to a relay. The relay controls the power supplied to the DC motor. On the control panel, the factory has a simple on and off. Now for the train and train track. The train is controlled by a NodeMCU attached to a motor shield similar to the Ferris wheel and carousel. The track has sensors and switches. The sensors are infrared sensors and the switches are servo motors. They're powered by batteries attached to NodeMCUs. The NodeMCUs read the switches and send out the signals for the servo motors to switch. On the control panel, the train has forward, stop, and reverse, similar to the carousel and Ferris wheel. You can see the speed and direction as well. The track switches have a section for the track switches, which is entering the station and leaving the station, and then another set of switches for the switches in the station. You can see the position of the switches as well. Underneath of the track sensors, you can see the sensor values, and then you can see where the train was last seen. I'll go ahead and make the train go around the track. As you can see right now, the track switches are set in the turn position so that the track enters the station. I'll go ahead and change the switches so that the train will bypass the station. The other button for the station switches can be used to load and unload any additional trains. As the train goes around, you can see the sensor values change. And it will update with where the train was last seen. The train just passed through the city and soon will enter the factory. And then come around to the entrance of the station. And then to show that the train can go in reverse as well. We've recently just constructed a LEGO replica of the Ben Hill Griffin Stadium here on campus. We plan to add lights and a NodeMCU controller similar to the downtown area of the demo. The LEGO IoT demo can also be deployed remotely. As you can see, I'm on LTE and not using the Wi-Fi. I'm also accessing the demo here on this website. To show that it works, I'm going to turn the train on. You can control every part of the demo remotely, as well as still view the live stream